Start. Let me share screen. Okay, if you are here and you should be able to hear me, I'm going to go look for some wipes real quick. We got 5 minutes before class starts. I need to go and see if I can find some more cleaning wipes. So hang tight. Okay. I should have turned my phone on. Then I would have heard. Okay. Oh, I wanted to try something real quick so I could write on the board. Where? That's not it. That's the. See if this works. I had trouble with this earlier. Why? That's so terrible. Okay. So that didn't fix it. There's that. Okay, so I can't write on it. Okay. All right. So I am doing, so that's our chapter 2. We still need chapter 1. Okay. So Zoom is up. We will do that in a second. Oh, I need attendance. I am in the wrong program for that. Okay. I'm going to start the attendance. I wish this thing would go away. There we go. Okay. And I'll let that go for a while. Maybe. There we go. And this is the one I want. We were all the way here. We did that. Okay, we're there. All right. I think we're going to start. I'll turn on my microphone. Sorry, y'all. Okay. And my Zoom is on, and I think, recording. Yes, recording to the cloud. All right. Okay, so we are going to do some iClicker stuff today. So everybody got your iClicker ready? You should do your attendance right now. I just put up the attendance so that one's rolling. And I'll leave it rolling until we do our first regular iClicker question. You should have watched chapter 2, sections 1 through 3, the videos. 1 through 4? Is that the 1 through 4? I think it was 1 through 3. That's okay. If you did more, it's cool. It's absolutely cool. So if you don't know what I'm talking about, this is the link for all the pre-recorded lectures, right? And it's a playlist. So when you click on it, and the internet works, it should take you to the playlist. But of course, it's going to take a while to load, right? And so at the top, you'll see chapter 1. That's all through 1 through 6. Here's chapter 2, sections 1 and 2, then 3, 4, 5, so on and so on. So I'll just keep adding to this. So if you want to bookmark this, whatever, the link's not going to change. It'll always be that same link on Moodle. And then here's the calendar, right? So what you should have done was submitted your homework 1, chapter 1 last night by 9 o'clock, which there was some timing things going on. I think it's in the wrong time zone, so I extended it to 8 a.m. this morning. I'm going to figure that out though. And then what you had to watch before today were sections 1, 2, and 3. Right? Everybody good on that? So this is the calendar you come to. What do I need to do for class? This is the calendar. All right. I'll do it twice. That's okay. All right. Any other questions on those kinds of things before we start material content? Okay, and let me look at my chat. I don't have my chat up. Okay, nobody's in the chat. That's great. All right. So I think what we ended with, we were talking about the graduated cylinder versus the beaker. We did that one, right? Yes, okay, good. All right, so we did that one. So now we're on 1.54. right? Now, this is really a great example of what you might actually see, 300 is too much, what you actually might see in a normal medical setting, right? A mother is to give her child 10 cc's of medicine every 6 hours. Unfortunately, she lost the syringe provided with the liquid medicine. She calls your clinic for help. How much medicine in teaspoons can you instruct her to give the child per dose and per day? So how many different answers are you going to have to give? You're going to have to give 2 answers, right? One answer we're going to want in teaspoons, so TSP per dose. And then another answer we're going to want to give teaspoons per day. So really we're looking for 2 answers here. And remember, when you're doing these, you're going to use dimensional analysis. And what you really have to focus on is, what am I trying to get to? What's my goal? So what I wrote over here on the side, that's my goal. That's what I want to get to. So what did I start with? I started with 10 cc's of medicine, right? Every 6 hours or every dose, right? So you could leave it as that, but if you wanted to say, every 6 hours, right? You could say, okay, so I know 1 dose is 6 hours. So your hours would cancel. Now we're in cc's per dose. Is that what we want? Is that our goal? Nope. cc's is not right. So how do I get rid of cc's? This is one of those, I would normally give you a conversion factor, right? But it's in your textbook. You have tables and tables of conversion factors. So what do we know about cc's and teaspoons? You have 5 cc's in 1 teaspoon. So does that give us what we want? Yes. So what's our answer? Our 6's actually cancel out, so you're gonna have to put that into your calculator. You just do 10 divided by 5 is 2. What are my units? And y'all need to have your calculators out, and you need to be putting these in your calculator, the same calculator you're gonna use on your exam. That's the one I suggest you use. Because if you're not doing it in class, you're not going to know what to do when you're on the exam. So have your calculator out, and please be doing these calculations with me. Okay, so what are my units here? 2, my cc's canceled, so 2 teaspoons per dose. But that's only half the answer. I also want to know how many teaspoons per day. So what should I do? So my teaspoons is good, it's my dose that's not right. So I need to go from dose to day. How do I go from dose to day? I'm going to put dose on the top. We know 6 hours, right? 1 dose, so 10 cc's every 6 hours, so it's 1 dose per 6 hours. And then what else do we know? 24 hours in 1 day. Right, exactly. So 2 times 24 divided by 6, what do you get? 8. 8 teaspoons per day. So that's something very common that happens. All right, let's try another one. Okay, a 38-pound child is prescribed a cycle of air for chickenpox in an amount of 80 milligrams per kilogram of body weight per day to be divided into 4 doses. Ooh, that's a lot of information. Each tablet contains 700 milligrams of the medicine. How many tablets should be given per day and per dose? So again, we're looking for two answers. We want to know tablets per day, and we want to know tablets. I guess I should do a different color, huh? Maybe make it easier. Tablets per dose. So that's our goal. Those are the units we want. So we have a 38-pound child. What are we going to do with that 38-pound child? What kind of dosage are we giving him? 80 milligrams per kilogram. So can we do that right away? No, because we have kilograms and we have pounds. Ew, that's terrible, right? So we want to get rid of pounds, so we put pounds on the bottom, and we want to get to kilograms, and I would give you that there are 2.2 pounds per kilogram. That's a very common one, but I'll still give it to you. Now we can talk about how much we're actually going to give them, and we want to give this person 80 milligrams per kilogram. So I know per 1 kilogram, the kid is going to get 80 milligrams. Is that our answer? So our pounds cancel, our kilograms cancel, we're in milligrams. Is that the unit we want? We're not there yet. We're not there yet. We still got a little ways to go. So now what? What? Well, let's talk about per day first. Where should this per day go? They're given 80 milligrams per kilogram of body weight per day. So this tells us how many milligrams. Do put this in your calculator. How many milligrams do you get? Should be like 1,381. Is that what you get? Good. All right. So that's how many milligrams you're giving them. How often are you giving them that? Look at the question. Per day. That was told to you right here, per day. But my answer is asking me tablets per day. So how do I convert milligrams to tablets? I have 700 milligrams in each tablet. So 700 milligrams in one tablet. So what do we get? I do hear some calculators. I love to hear that calculator clicking. So 2. And what you actually got when you put it in your calculator was probably 1.97, right? But can you give that in 1.97? Why not? I'm given 2 significant figures, 1 significant figure, 1 significant figure. So I can only give 1 significant figure. So I'm going to give that as 2 tablets per day. I guess I should have done that one in red. That's okay. So this is my answer to the first part. I'm in tablets per day. I give a check mark. Yes. Now I need to go to tablets per dose. What can we say about how many doses we give in a day? 4, because we divided it into 4 doses. So in one day, I put 4 doses. I give the child 4 doses. How do I know which unit to put on top and which to put on bottom? That's the trickiest part. You just put it so they cancel out. That's right. I wanted my days to cancel out because I wanted tablets per dose, and that's what I get. So 2 divided by 4 ends up in 0.5 or 1/2 of a tablet per day. What's that? Per dose. I'm sorry. You're right. You're right. Per dose. Thank you. BLET, tablet per dose. Thank you. Okay. Let's try another one. A child must take 10 milliliters of cephalexin, an antibiotic, by mouth 2 times a day for 10 days. The solution was provided as a 50 milligram per milliliter solution. How many milligrams will the child have taken when the course of the medication is over? What should the units be for our final answer? Our goal should be milliliters. So if you know where you're going, you can get there. So the child must take 10 milliliters of our antibiotic. They're going to take it how often? They're going to take it 2 times per day, right? For how many days? 10 days. Because I really need to get rid of my days. I really want my final answer just in milliliters. Not in milliliters. Oh, it's milligrams. Oh, yeah, milligrams. Okay, so the solution is provided as a 50 milligram per milliliter suspension. Well, I know my milliliters cancel, so my 10 mils is on the top, so I want to put milliliters on the bottom. So I know I have 50 milligrams in 1 milliliter. So it's 10 times 2 times 10 times 50. What do you get? A big number. 10,000. My milliliters canceled. This is a real practical application of dimensional analysis. Like, you might really have to do this in the clinical setting. Will you have to do this on the exam? Yes. Yes, you will have to do this on the exam. Yes. Okay. All right. Let's see. And I should have been doing the odd ones on the video. I must have missed this one. A patient gets 2 liters of fluid over 18 hours through an IV. The drop factor is 20 GTT per milliliter. Remember that GTT just stands for drop. So that's drop per milliliter. Calculate the drip rate in drops per minute. Okay, so what are we starting with? They're getting 2 liters of fluid over how much time? 18 hours. So we're trying to convert to drops per minute. This is our goal. So I like to do the time first because it's super easy, right? So I'm trying to go from hours to minutes. So I know that in 1 hour, I have 60 minutes. So I've got my minutes, that's great. Now I need to go from liters to drops. How can I do that? What other conversion factor am I given in the problem? I'm given drops per milliliter, but I'm in liters. So can I use it yet? Not yet. I got to do something else. I need to get rid of my liters and I need to convert to milliliters. Here's one that you have to know. How many milliliters are in a liter? Remember a liter of Coke? There's 1,000 milliliters in 1 liter. That's one you have to know. Now I'm in milliliters and I can use my conversion factor. So it told me that there were 20 drops in 1 milliliter. So it's 2 times 1,000 times 20 divided by 18 times 60. I did not get 80. Anybody else get something different? 37, that's what I got. Sometimes it's just plugging it into the calculator wrong. And my units should be in drops per minute because my milliliters canceled, my liters canceled, so I'm left with drops per minute. Good? Maybe? Is it a tough Tuesday today? Hmm? So in this one, oh, in this one it really should be 1 sig fig here. I was looking here, this is 2, this is 2, so really it should be 40. Good call. Good call. You do have to worry about sig figs. A lot of times book problems will do that, and what they should do is write, instead of 20, they should write 20 point, but they don't. I don't know why. But so your answer should be 40. That is correct. Okay, how long would it take in hours? So here's my goal, how long in hours, that's my goal. To administer exactly 500 milliliters of fluid through an IV with a drip factor of 30 GTT per mil if the drip rate is 60 GTT per mil. I'm gonna look, I got a question over here, how did you get 40? I did a rounding. So if I know I can only have one significant figure, the 3 is significant, that 7 means we're gonna round up. And I can't just drop that place value.
Open the screen, ma'am.
Open the screen?
You want to bend over the screen?
I want to bend
Can you
it.
catch it?
No.
I'm so sorry.
No, it must be next
so
door.
sorry.
No, you're okay. You're okay. So you want to round? So that 7 rounds that 3 up to a 4, but you have to leave a place value. So it's not just 4, it's 40. Okay. All right, so let's go back to 1.60, right? Okay, so how long would it take to administer exactly? We're starting with 500 milliliters of fluid through an IV with a drip factor of 30 drops per milliliter if the drip rate is 60. Okay, so what are we going to do? We're starting with 500 mils. We want to get rid of our milliliters. So what are we doing? Right? So we got 30 drops per mil. Okay, but we want to get to hours. Our milliliters cancel, we're in drops. Now what? Use your other conversion factor. Your other conversion factor, we're going to get rid of drops, and we're going to get to minutes. So we know we have 60 drops in 1 minute. Are we good? Nope. Nope, because we want hours. So our drops canceled, but we're in minutes. So we know we have 60 minutes in 1 hour. So now we're in the units we want. We're in hours. We just have to do our multiplication. So 500 times 30 over 60 times 60. So what are my units? What are my units? What is my answer? What do you get? 4 hours. What did you get in your calculator? 4.16 repeating. But we can't, but y'all are so right that we can't leave it like that, right? Because we have how many significant figures? 1 significant figure in all of our values. So we need 4 hours. So check those sig figs. Okay, last one. This one's a percentage. Okay, a medium-sized carrot weighs 61 grams and contains 6 grams of carbohydrate. What percent of the carrot is carbohydrate? So whenever we do a percentage, whenever you want to know the percent of a part, right? It's the part over the whole times 100, right? So how are we going to set this one up? What's our part and what's our whole? Right, 61 is our whole carrot, and 6 grams of carbohydrate is our part. So we know, yeah, so we know we want our 6 grams is equal to some percent of our total grams of the carrot, right? So then we know percent is really over 100, and so we just cross multiply, and we do 100 over 61. So what do you get for X? And don't forget, Hayden, to multiply by 100 if you do it that way. Multiply by 100, because you want to get a percent. Yep. So you get 9.8%. But tell me about sig figs. What do you get? 10%. Good. Feeling pretty good about this? We're gonna try some clicker questions. All right, we're gonna see how we do. And we'll go over the answers and why as we go through them. Any questions on this before we move on? We're not really moving on. We're just changing gears a little bit. All right. So what I've found out is that when I have a PowerPoint presentation, now we're gonna see all the answers. Here we go. When I have a PowerPoint, if I write on the screen, like I'm writing in the upper left-hand corner, ooh, that's better. But it's about a gap of this far, so I can't really write on the screen and know what I'm doing. So we'll have to kind of do our best without me having to write. Okay, so I'm going to turn off our attendance. Everybody should have responded by now. And we're going to try a multiple choice question. So which of the following is not a pure substance? Steam, ammonia, gasoline, or iodine crystals? And I'll give y'all typically about 45 seconds to answer. Should be plenty of time. Unless it's a calculation, and I'll give you more time. How many people responded on the attendance? Was it 40? That was more than 40. Okay, I'm calling it out in a minute. So if you haven't responded, please respond. That's one thing about my class. Please don't leave it blank. Please don't ever leave anything blank, especially if it's a multiple choice, because you got a 1 in 4 shot of getting it right. So please don't leave anything blank. That just makes me want to cry when there's something blank. Okay, so what did we say? Which one of the following is a pure substance? You have a problem? What's the problem?
It's not liquid food, because I just already marked it off on it.
Okay, hang out after class and like try and write things down as we go and keep trying it, but I've not heard that yet. Okay, so which of the following is not a pure substance? So C is correct. If I could click it. Oh, because it's still going. C is correct. So when we look at these, is steam a pure substance? Why is steam a pure substance? It's all water. It's all H2O. Water is a pure substance, pure water, pure substance. Pure ice is a pure substance. It's all made out of just water. Ammonia, same thing. It's all just ammonia. There's a chemical formula for ammonia, just like there's a chemical formula for steam. Iodine crystals, same thing. It's just iodine. It's not a mix. So the only one that is not a pure substance, that is a mixture, is gasoline. Oh, here. Y'all, I'm learning this. I'm trying. Okay, so gasoline, we said, is not a pure substance. Which of the following substances can be classified as a homogeneous mixture? I'm calling it in a minute. Okay. So what do we get? Which one of these can be classified as a homogeneous mixture? Ooh, we got a big spread here. So our homogeneous mixture is salt water. Remember, what does homogeneous mean? Basically all looks the same. Oil and vinegar, does that all look the same? If you're boiling water, you're boiling pasta, and you put a little oil in the water, does it dissolve? No, it stays separated. So that's a heterogeneous mixture. How about hydrogen? Is that even a mixture? No, that's a pure substance. How about water? Pure substance. Okay. All right, here's a little bit of a tricky one. How many hydrogen atoms are in this molecule? Five seconds. Give me some kind of a response. Okay, so what do we get? 24 is correct. 24 is correct. How did you know that? You had 3 hydrogens here. Then how many hydrogens are here? 14, because if you have a number on the outside of the parenthesis, that's telling you to multiply. So you have 14, 15, 16, 17, and then you have another 7 to make 24. Okay. All right, oh yeah, I tried to write on that, it was not working. All right. I can do this. Okay, what element is in period 5 and group 3A on the periodic table? 5 seconds. Tell me something. Okay. So you should have picked indium. Should have picked indium. So we're in period 5. So here's period 5. And we want to go all the way over to group 3A. Should I stop right here? On yttrium? On Y? Why not? That's 3B. So those are transition elements. We're talking about 3A. 3A is our main group element. So we got to come down here to indium. So be careful about that. All right, you want a sheet of paper to try this one. I'll give y'all a few minutes, like 5 minutes to figure this one out. So what is the coefficient for O2 when this equation is balanced with the lowest whole number coefficients? And y'all remember, if you're struggling with it, 70% of your eye clicker is an A. Okay? So getting one wrong is not a big deal. Just remember that. Okay, so I was gonna call it at 5, but I've got one more minute. So at 6 minutes, I'm calling it. And then put something, take a guess. All right, I'm calling it. Okay, so what do we got? Oh, we got a big range. So you should have picked C. You should have picked C. So this should be your balanced chemical equation. Your coefficients should be 2, 7, 4, and 6. Now, I found this out last period that when I'm in PowerPoint, for some reason, it doesn't communicate very well and I can't write very well. But I want to show you how I balance that. So I agreed last period that tonight I'm going to go home and make a quick video. So what I imagine I'm probably going to do is make a little like extra video on balancing equations, because I think a lot of people struggle with this one. Yeah. Okay. So I'll do a little balancing equations extra video. You can watch it if you want to watch it, and it'll have this answer in there and how I did it. Okay. It was a big struggle last class period, so I'm not going to subject y'all to that too. Okay. All right. Let's see. Okay, next one. Which of the following is a chemical reaction? Okay, that's 1 minute. If you didn't put a response, put one. Still missing a few people. Put something. Okay, I'm gonna stop it. All right. So that is correct. B is correct. Rusting of iron. Liquefying of oxygen. All you're doing here is changing states, right? Melting of ice. What is that again? Change of state. Change of state is a physical change. You're not changing the substance. You're still oxygen or you're still water. Doesn't matter. You're just changing state. So that's physical. Slicing a ham is like tearing a paper. You still have ham. So you didn't change your substance. Rusting of iron, though. That is the iron reacting with oxygen in the air and making iron oxide. So that is correct. Rusting of iron. Okay. What is the percent by mass of salt in a mixture that contains 150 grams of salt, 1.2 kilograms of flour, and 650 grams of sugar? I will give you a minute. You should probably use a sheet of paper. I'll give you more than a minute on this one. I meant to say that. Not that I'm gonna give you a minute. I meant to say I'll give you 3 or 4 minutes. So I'll give you until 4 minutes. 1 minute left. Okay, wrap it up. If you haven't given a response, take a guess. I'm gonna close it. Take a guess, take a guess. Okay, so what do we get? So you should have gotten D, you should have gotten 7.5. So I'm gonna show you how that works. This one I actually typed out. So now I know I have to do this again. So when you're doing percent by mass, right? We know percent by mass is percent of the part. In this case, they're asking for salt, which is equal to the grams of that part over the grams of the total times 100. But the problem is that they don't give you the grams of the total, right? So that's something you have to go and find. So how do you find the grams of the total? You have to add up the components. But when you looked, what was your flour in? It was in kilograms, and the others were in grams. So you could have converted all of them to kilograms or all of them to grams, doesn't matter. But it's easiest just to convert the one from kilograms to grams, then add up all the pieces and get your total, and then plug that into your formula. And you should have gotten 7.5%.
So if I got, the, like C, I got the right answer, but I used the decision, right?
You didn't multiply by 100. That's what happened. If you got C, you didn't multiply by 100. You just left out that last step right there. Okay. All right. Here's an easy one for you. How many significant figures are there in the following number? 0.00458 grams. Okay, at 1 minute, I'm calling you. Okay. So what do we get? You should have gotten that there are 3 significant figures. Because the decimal is present, right? You're going to come in from the left-hand side and cross out all those zeros until you get to the first non-zero number. Once you're at that first non-zero number, you count every number in the rest. So you have a 4, the 5, and the 8. They're all significant, so that's 3. Okay. The average diameter of a human cell is 0.00, let's see, 0.000050 meters. How many significant figures does this measurement contain? Do we have 48 people? Not 47? Calling it at a minute. Okay, so what did we say? That is 2 significant figures because the decimal is present. So you cross out all those zeros until you get to your first non-zero number, and then after that, everything is significant. So the 5 and the 0 are significant. Good. All right. Here's a little bit of a tricky one. Identify the number of significant figures, aka the number of places past the decimal, that the syringe measurement should be reported. So your big hatch mark is the 0.1 and your little one is 0.01. Calling it at a minute, so 5 seconds. Okay. So what did we say? All right, be careful with this one. Yeah, I'll be careful with this one. It's 3. 3 significant figures are 3 places past the decimal point. Why? Whenever you're looking at something that has graduations and you're trying to take a measurement, you're going to look at all the digits that you can for sure say, and then you're going to estimate one more. So I know I can say these big tick marks, right? So that's 1 place past the decimal. Then this little tick mark is a 0.01, right? So I can count that as the 2nd place past the decimal. Then my 3rd one I have to estimate. So what if, I don't know if y'all can see this because it's like so tiny, but do you see where my little pointer is right there? Can you see it? What would I give that measurement as? If I pulled up volume in that syringe to that point, what would you call that? 0.15. Now I'm between the 0.15 and the 0.16. So what's about halfway between that? It would be 0.155. Y'all see that? So how many, so it should be 3 significant figures. It should be 3 significant figures. Does that make sense? So I'm going to give you exactly the same syringe, and I'm going to give you a volume, and I want you to measure it. So how many significant figures are you going to give me? 3. 3 significant figures. Now, I know you can't do this on your iClicker. I know you can't do this. Write it down. What do you think it is? Write it down. I know you can't do it on your clicker. If I do a clicker thing, it'll show on your screen though, won't it? I know that's really far away to look at. But you can see it on Zoom. Can't you see it on Zoom? Yes. You have to tell me that. I'm gonna give you the answer in a second. You do. So what you should have reported is 0.370, right? Because when I'm looking at this, right, the big tick marks are 0.1. So I've sucked up 0.1, 0.2, 0.3, 0.35, 0.36, 0.37. Now it's on that line. So I have to estimate the next digit. Well, if it's on the line, what's my estimation going to be? 0. So yes, you do have to. Yes. Make sense? You have to be able to read a syringe. That's really important. Really, really, really important. Okay. Tell me how many significant figures are in the reading on the thermometer? Okay, 10 seconds. 5. Okay. So what did we say? How many? There are 4. Good. There are 4. Whenever you look at a digital readout, can you do any estimation? Is there anything to estimate? No, all you can do is report what's there. So 101.8. Where's the decimal? Present or absent? Present. So I'm going to come in from the left. Our first non-zero number is a 1. Everything after the 1 is significant, so all 4 are significant. All right? All right. So said 4. All right, convert 236 kilojoules into calories. So I need to give you a conversion. There's 4.184 joules in 1 calorie. Okay, there's your conversion factor that I forgot to give you. I'll give you a few minutes to do this one. So how many videos are there of me with headband hair? Terrible. Bless you. Okay, I'm gonna call it at 3 minutes. I'm gonna call it at 3 minutes. Ten seconds. Put something. Yes. Okay. So what did we get? Okay, now you got to be careful. I'm going to tell y'all to be really, really careful. When you were doing this, be careful of the units. Most of y'all picked D. You picked 56.4 calories. Well, when you convert from kilojoules to joules and then joules to calories, you get 56,450 calories. Is that an option? It's not. But what is an option? 56.4 kilocalories. What's a kilocalorie? All you do is convert, right, metrically. In 1 kilocalorie, you have 1,000 calories. You get 56.4 calories. So be careful, and check your units. Y'all aren't checking units. Be careful, okay? One of those sort of tricky ones. Okay, this one is one that you cannot do with the clicker, but I wanted you to practice one right here. So Just put it on paper. You're gonna have to write. You're gonna have to write to do this one, so get ready. Melatonin can be prescribed to children from 1 to 8 years old to reduce anxiety before surgery. If you have a 50-pound patient and the dosage is 0.5 milligrams per kilogram, how many grams of melatonin should you give your patient? Be sure to use the appropriate number of significant figures in your answer and the units in grams. Raise your hand if you need some more time. Okay, y'all ready? Yeah? Okay. So what did you get? You should have got an answer of 0.01 grams, right? We start with the child weighs 50 pounds, but we can't keep it in pounds because our dosage is in milligrams per kilogram. So we convert from pounds to kilograms. Now we want to be in milligrams, so we've got to convert kilograms to milligrams, and then we know we're doing it in 0.5 milligrams per kilogram. And then we want to know how many grams we should give the patient, so we convert milligrams to grams. Okay? Everybody okay on that? Okay, last one. Last one, a percentage, just like the last one on the in-class problems. This is one you can't check in on. A package of beef jerky says that there are 2 serving sizes. 1 serving size is equal to 28 grams in the package. Additionally, it says that there are 16 grams of protein per serving. What percentage of the package is made up of protein? Okay, anybody need more time? Raise your hand. Yeah, okay. Okay, y'all ready? So what did you get? You should have gotten 75%, right? 75%. So if you know that there were 2 servings in there, right? You can convert, you know there were 28 grams in a serving. So that gives you a total of 56 grams. Then you can say your part, which is your protein, 42 grams of protein, over your whole, which is 56 times 100, you should have gotten 75%. Yeah? Okay, so I'm gonna admit something that I did not plan for this to take quite this long. So we were supposed to have started on chapter 2 today, but we are just finishing chapter 1 today. So if you go real quick to Moodle and you go to the pre-recorded lecture schedule and homework calendar, I updated that. And so you have to watch sections 4 and 5 before class on Thursday, and we're going to do a bunch of problems from chapter 2, right? But that moved our homework back. So the homework was going to be due on Monday, but we're going to finish chapter 3 on Tuesday, so that'll make your homework due on Wednesday. So this is where you should be going to check to see what's due when and what to watch and all that. This is the file. So if you're on Moodle, first day material, syllabus, and calendars, this is your go-to. You need to keep coming back to this. And where do you go to get those recorded lectures? Right up above, YouTube playlist for all pre-recorded lectures. They're all there. Any questions on that? Y'all have a great rest of your Tuesday. It was good to see you. And if you have any questions, let me know. And I'm gonna turn on my microphone. Go ahead.
On the last one, I thought it was so 16 times 2, that's 32, huh?
Oh, did I do the math up? I don't know what I did.
Because wasn't it 16
It's 28 grams
per serving size? Okay, so you
per
multiply
serving
that, and
size,
that's
so you get 56
And then 16 per serving.
per
right?
serving. So, but we want to know in the whole
package.
thing.
So 16 times 2 is 32. Not
Oh, not 42.
So
Yep.
it's 57%.
Yeah. Oh, y'all are right. You're right.
So
Okay,
if I got the rest
you got it.
wrong, I'll need that one.
You got it. 57. So that's what they were saying, that I multiplied, I wrote 42 and it should have been 32. That's my mistake, my typo. Should have been 32 on that last one. I multiplied by 2 and somehow got more than that. So that was my fault. Should have been 32. Look on the homework calendar right now. Pull up, no, I want you to pull up the homework calendar so that you don't have to ask me.